characteristic of convective clouds during Chuva campaigns. This is by Wagner and Luis, but I believe that Luis will make the presentation.
Okay, so I will present the Wagner work. He didn't want to present, so he asked me to present and trying to convince him to present. But he will help me to explain the results. So the idea, it's one of the goals of the Chuva is trying to see if there is difference between space and time organization of the convection in the different regions. So Wagner is in charge to do that job and see from the satellite point of view and from the radar point of view what is the typical organization from each region. So we are going to present only the results for satellite because the results for radar he is still working on. So this is the criteria. He follows systems that have more than 20 pixels using channel 4 brightness temperature, using satellite with 4 kilometers resolution, and follow the 235 Kelvin structure. So this is first results. This is the propagation. So it's interesting to compare with the one that was discussed yesterday of the propagation. So a direction of propagation, also the speed, and the propagation speed is larger than 10 meters per second is red. So the first thing you can see, this is Fortaleza, Belém, and Vale do Paraíba and Santa Maria, that in Santa Maria the systems propagate much faster than the other regions. In Vale do Paraíba you can see that systems accelerate when this goes to the ocean, that probably small, how can I say it? Yeah, hopeless. And so the propagation is typical from east to west, and in Belém you can see here the rivers and some propagations, but mostly in these directions. Same for Fortaleza, that systems propagate of the campaign. So here in Fortaleza you can see the coast was the maximum frequency of occurrence. Here in Belém you can see that there is a lot of convection between the rivers here. Here in Santa Maria, I think this is the mountains, right? Who is from Santa Maria? This is the mountains in Santa Maria. And in Vale do Paraíba was a more specific presentation each month. Here is November, December, January, February, March, and for all regions. So for all regions, it's interesting that maximum rainfall was over the radar region, in the triangle. So all these figures are centered in the satellite. You can see the difference from each month. What January is the month more active for Chuva Vale do Paraíba. We see also the importance of the mountains. Has some discussed by Julia, and probably these are the what's called microscope lines. And Wagner, the delivery gave me the wrong presentation. I think so. Do you have the right one? Sorry for that. We have the size distribution for the system. We have a figure that put all the distribution together, and you can see that there is no much difference in size distribution from the cloud organization, only for the Santa Maria that has the biggest one. And the next step that Wagner is gonna do will be the efficiency, to understand the efficiency of each region to produce rainfall from the amount of clouds. So it's a relationship between the frequency of clouds and the frequency of rainfall. So you're gonna give an idea about the efficiency in producing rain for each region. And also, there is the triangle of radiosome. And this triangle of radiosome, he has already computed the thermodynamics parameters, escape, instability, so everything from this triangle. And the dynamic as surface, you mean mostly convergence in the surface, upper level divergence, shear, and compare these mechanisms to the produce of rainfall in each of the regions. So he has the triangle, he has the area covered by the triangle by the clouds or by the rainfall, and then can analyze based to the quantity of escape and stability or any dynamic approach. Sorry that I had the wrong presentation here. Thank you very much.
Thank you. Question, comments? Yes, please.
Yeah, exactly. So, yeah, actually he put in the 1 kilometer, but it is a class that goes, what is the class of? That's it, the radius, but has 1 kilometer. The satellite has 4 kilometers square, 16 kilometers square. Qual? Então, aqui está o quilômetro, 1 quilômetro. No, this is the class. It is not. It's the class. The class goes up to. Qual é a classe? Intervalo de classe.
Um é 3.14.
Como a classe não seria? Desculpa. Ah. Radius. Oh, so it's not size, it's mean radius. Oh, so this is radius, not size. So as the class, it's between, goes up to 4. So here is the class of 5, but it goes from 5 to 10, you know? It's just,
so it's actually
this is the small guys.
radius because it's not going to be a circle, right?
No, it's still, yeah.
You calculate the total area.
Yeah, we call effective radius.